Hi everybody, we're going to talk about notes from the 8th grade Common Core lesson 3.4. We're talking about similar triangles and using similar figures in order to go ahead and find indirect measures. You need to be familiar with the definition for similar triangles. Similar triangles are identified when two angles in one triangle are congruent with two angles in another triangle. Because two of the angles are congruent, the third will also be congruent, and we call those triangles similar. So, similar does not mean they are the exact same shape. It can be larger or smaller. We're simply identifying similar triangles based on their angle measurements. So, if the angle measurements are congruent, all three, then both the triangles are similar. In the first example, there are two sets of triangles, and we're going to try to identify if those triangles are similar by going ahead and comparing their angle measurements. In the first triangle, they are given 28, 80, and x, and the second one, 28y and 71. The interior angle sum of a triangle is 180, so I set up an equation to solve for x. 28 plus 80 plus x equals 180. 28 and 80 is 108. 108 plus x is 180. I then add negative or subtract 108. I end up with 72. So this x is representative of 72 degrees. In my second triangle, I go ahead and set up another equation. Angle sum is 180, so 28 plus y plus 71 equals 180. 99 plus y equals 180. I subtract 99 or add negative 99. This ends up equaling 81. The first triangle has an angle sum of, or the angle measurements of 28, 80, and 72, and the second one has angle measurements of 28, 81, and 71. They are not the same, and therefore they are not similar. So these triangles are not similar based on them not having congruent angle measures. Let's look at the second one. I have a 90 and x and 66, which means I'm going to set up an equation. The angle sum of triangles for the interior angles is 180. I have 156 plus x equals 180. I'm going to subtract 156. I end up with 24. So this missing angle up here is 24 degrees. I'm going to set up a similar equation down here. Y plus 90 degrees plus 24 degrees equals 180. Y equals 104, or y plus 114 equals 180. I'm going to subtract 114 or add negative 114. 66. So this angle ends up equaling 66 degrees. Oh, wait. I have a 90, a 24, and a 66. I have a 90, a 24, and a 66. Because the angle measurements of these triangles are congruent, therefore the triangle is similar. So I'm going to say yes. Yay. It's similar. Okay. Please be aware that when I draw, I'm not using a protractor, so and my drawing's not great either, so I'm not using a protractor, so my drawings typically aren't to scale. What you need to understand about example 1 is that when you have two or more congruent angles within a triangle, those triangles are going to be similar. And we can go ahead and use what we know about similar triangles to find missing measurements. So this indirect measure, which uses similar figures to find missing measurements, only works when it's been stated that these triangles or the figures have been similar. So saying right now, these figures are similar. I then can go ahead and know that the ratio of, because they're similar, the ratio of the triangles is going to help me find what the missing angles are. So the height is x, and the base of this triangle is 40. The height of this triangle is 60, and the base of this triangle is 50. Again, not always drawn to scale. So I can go ahead and set up a proportion. Set the height compared to the base is equal to the height compared to the base. I'm comparing height, height, base, base. And then I can go ahead and solve this proportion using an equation to solve for my missing side length. So 50x is equal to 40 times 60. 50x equals to 2,400. I divide by 50. Okay, I'm going to walk over here and do my long division for it. 2,400 divided by 50 is the same as 5 going into 240. 5 goes into 24 4 times, that's 20, and 5 goes into 40 8 times. So x is equal to 48. That means that x is equal to a height of 48 feet. Because they are similar, I can set up a proportion and I can compare similar sides in order to find the missing sides. So if you notice the way I set up my proportion, I did height, base, similar to what we've already done with proportions earlier in the year. I do want to bring this to your attention. This is how we indicate that triangles or figures are similar with a similar sign. Let's recap what we should be doing with notes. You should be starting and stopping throughout the video in order to go ahead and write down all the information. If I write it down, you write it down. Now, if something is confusing to you or you have a specific question about a question, you should be jotting that question down or sending an email about it. The purpose of notes isn't for you just to go ahead and haphazardly watch the notes. You need to understand what the heck I'm talking about. And if you have questions about that, you need to be prepared to ask them either prior to class or during class. So, you need to be familiar with the definition for similar triangles. You need to be able to identify similar triangles. And you also need to be able to use similar triangles to find missing measurements. Thanks, guys. Have a good one.